Okay, we're going to start by subtracting two polynomials. Adding is kind of the same kind of deal. It's actually easier because you don't need to distribute anything with addition. But if I wanted to write this without parentheses, I would have to distribute this negative to all three terms. So I'd get 3x to the third plus 8x squared minus x minus 4 minus 5x to the third plus x squared plus 17. And then I just want to combine like terms. So let's see, I'll start with the highest degree terms. I've got 3x to the third and negative 5x to the third. That's negative 2x to the third. And then let's see, I've got these squared terms. That gives me 9x squared. And then there's only one x term. And then negative 4 and 17 would give me 13. What am I talking about? No, that's right. Okay, negative 4 and positives. There we go. And then that's finished. And you usually write it in standard form in descending order of terms. Okay. All right, next up, I'm going to simplify this, and I'm multiplying these two binomials together, and we're going to FOIL. First, outer, inner, last. So first, 2x times x is 2x squared. Then I've got outer, 2x times negative 1, negative 2x. Inner is 3 times x. Last is 3 times negative 1. Combine my like terms, which are the middle terms there. So I get 2x squared plus x minus 3. Okay. So that's how we can multiply binomials. The next example, I've got a binomial and a trinomial. FOIL is not going to work here, so I need a different method. Okay. One thing you could do, you could take the 2x and distribute it to these three terms, and then take the 3 and distribute it to all those terms. And that, in essence, is what I'm doing. I'm just going to set this up like a multiplication chart, though, so that I can keep track of everything and make sure I don't miss any of the pieces. Okay? And so I'm going to take the two terms from the binomial, and I'm going to line them up vertically like that. And then I'm going to make a box. Okay? And on the top, I'm going to take these three terms. Okay, and you know, I didn't put the plus because I'm just writing the value of that term, but I did put the minus because that term is negative. I mean, it wouldn't really be a big deal if you put the plus in. But then what I'm going to do is think of this as a multiplication chart. A multiplication table like our old times tables. Okay, and in the first box I'm doing 2x times x squared, so that's going to be 2x to the third. Need a new pen. All right. And then 3 times x squared down here would be 3x squared. 2x times 2x is 4x squared. 2x times 3 would be 6x. And then let's see, 2x times negative 4 and 3 times negative 4. Okay? And then what I do is I take the contents of all of these boxes and they'll give me my solution. Okay? So I am noticing as I go, I'm going to combine some of the like terms. I do have some like terms. These two are like terms, and these two are like terms. Okay, so I'm just going to combine those as I go. So 2x to the third is my highest degree. Then I've got 3x squared plus 4x squared to be 7x squared. 6x and negative 8x is negative 2x. And then I got the negative 12. And there's my solution. And the nice thing about this method, you could actually do this method with binomials as well. You could do it if you had two trinomials, or if you had, you know, if you had one of your polynomials is 10 terms and the other is 20 terms, you could do this. It doesn't matter how the number of terms you have. You can use it with any polynomial when you're multiplying two polynomials. Okay, so that's the method I'm going to use here. So you can try it out here if you like. I'm going to get straight to it. Setting up a multiplication chart. It doesn't matter which polynomial you put on the top and which is on the left. You should get the same result. Okay, and then I just start multiplying away. And hopefully I don't make any mistakes here. Let's see what happens. Okay, I think I'm looking good there. And then I'm going to start all the contents of the boxes. I add them all up. So I've got 2x to the fourth. And then this kind of pattern happens a lot where the like terms will be on diagonals. It's not necessarily going to happen. Depends what the original polynomials are. But that happens a lot. So 6x to the third and negative 2x to the third is, whoops, it's going to be 4x to the third. And then let's see, that's negative 8 plus 3, negative 5x squared, 11x, and negative 3. And there we go. Okay. All right. So, next problem. Very common mistake that people make when they have a binomial that they're raising to a power. They'll just say, oh, this is x to the third plus 2 to the third. So that would be, x to the third plus 8. But this is incorrect because this is x plus 2 times x plus 2 times x plus 2. So you can't just square the front and back. It's going to take a lot more work than that. So what you'd want to do is think of it like this and then multiply those two bits first. So I'll FOIL that. So first is x squared, outer is 2x, inner is 2x, and last is 4. Okay, and I'll simplify a little bit there. Oops, I'm off screen a little bit. Okay, so I've got it down to this, and now I would want to use the multiplication chart method. So let's see, I'll do that up here. So x4, there's my trinomial. Here's the binomial. Okay, x squared times x, x to the third. Okay, and then I'll start combining all those terms in the boxes, and I've got some like terms on the diagonals again. So let's see, x to the third, got 6x squared, 12x plus 8. Okay, so there we go. All right, so next up, I'm going to do the same problem. Notice this is the same problem, so I already know what my answer should be, but I'm going to use a different method. I'm going to use Pascal's triangle, okay? And here's what Pascal's triangle looks like first. So you got kind of a pyramid thing going. So you have a 1 on top, and then you put 2 1s like that, okay? And you're actually going to keep getting 1s down either side of the triangle, okay? But then when I'm looking at what this number is going to be right here in this slot, you take the 2 numbers directly above it. So 1 plus 1 is 2, so this should be a 2, okay? And I'm going to continue the 1s down here. And then these two are getting together and forming that number, right? Same thing here. Those two will give me this slot. So 1 plus 2 is 3. Same there. 2 plus 1 is 3. And you can continue, as long as you know how the pattern starts, you could build this on infinitely. So 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4, and then I get another 1 down the side there. Okay, I'll go one more row. Okay, so there's Pascal's triangle. All right, and you might these are all called rows, right? And you might think that the top row would be row 1, but you'd be wrong. This is actually row 0. Okay, and then so I've got row 1 right here. This is row 2, row 3, and so forth. Okay, and again, this goes on infinitely, but that's more than we need for this problem. Okay, so what I want to do is start with the exponent. So this tells me what row to use. Okay, so here I'm going to use row 3. Okay, and now I'm going to set up a little chart. So the top row of my chart is going to be the numbers from whatever row I'm on. I'm on row 3, so I'm going to set up 1, 3, 3, 1. 1, 3, 3, 1, like that. Okay. Now below the triangle, I'm going to have row A and row B. I've got my different columns set up like that. Okay. Now the A is the first term of the binomial, and the B is the second term. Okay, so I'm going to put X as my A's. I'm going to put an X all the way across. Okay, and then my B is 2, so I'll put those all in the B row. Okay, but I also want to put some exponents in the A and B rows. So what I'm going to do with my first A, since I'm in row 3, I'm going to raise this to the third. And for this particular problem, it doesn't really matter if the X is in parentheses, but if you have a more complicated A term, it would be a good idea to put that like if it were negative or if I had different variables. So it's kind of just a good practice to put these in parentheses. It's not going to make a difference with either of these rows. But it will help later on when we have more complicated problems, okay? So this is a 3, and what I'm going to do after that, I'm just going to work my way down from 3. So I'm going to subtract 1. I'll go 3, 2, 1 until I get to 0, and you should end up at 0 on the last one. If you didn't end up at 0, then you used the wrong row from Pascal's triangle, and that's going to ruin your answer. Okay. What I'm going to do on the second row is go the opposite direction. Okay, so I'm going to start with 0 here. And so I want in this column those two to add up to 3. So if I want these two to add up to 3, these two exponents, this would have to be a 1, right? And then what's going to end up happening on this next row is I go 0, 1, 2, 3. Okay. All right, so now that I've got the chart filled out, this first column is going to give me the first term of my solution, okay? So I'm going to use, well, I'll just put it in parentheses. So I'm going to have 1 times x to the third times, and you got to remember that anything to the 0th power equals 1. Okay, so let me do that up here. 2 to the 0th equals 1. Anything to the 0th power equals 1. So that is going to give me my first term. Okay. So hey, that's going to be x to the third, which is what I got up there. So I know that's correct. Okay. And now let's try this one. So I have 3 times x squared times 2, and that would be 6x squared. Hey, that's the same result I got up there, right? And then I've got 3 times x times 4. That would be 12x. And then remember, this is 1 times 1 times 8, right? I'm simplifying this as I go. 2 to the third is 8. And that gives me 8. and hey, it's the same result. And it might seem like that is a lot more work than just multiplying it out. And that's because I've got a relatively low exponent, and also it's the first time that we've done this. But Pascal's triangle can actually save you a lot of time. So even when we've just got something to the 4th power, it does save a lot of time. So let's try it out with this one, okay? So I'm looking here and I see, oh, I should use row 4, and row 4 is 1, 4, 6, 4, 1 right up there, right? So from my triangle, 1, 4, 6, 4, 1. Give yourself a little space because it'll get a little crowded in there if you don't. Okay? And then my A term is 2x, and I definitely want to put that 2x in parentheses. I'll put that all the way across. So, you know, it took me a while to explain how to do the first problem, but once you get used to the pattern, it's pretty quick to fill out this chart. And then, I don't know why I put a little bracket there, but my B is 3. Don't really need the parentheses, but I'll just do that because it's a good habit. Okay. Okay, and then I want to put in the exponents. Sorry, I was off screen a little bit. I want to put in my exponents. So this is 4th row, so I'm going to start with a 4 and then work my way down to 0. Okay, and I'm always going to start with a 0 on my B row and work my way up like so, okay? And then I just multiply each term. The alternative to Pascal's triangle here would be doing 2x plus 3 times 2x plus 3 times 2x plus 3 times 2x plus 3. So you could do, you know, 2 rounds of FOIL and then multiply those together, but you can imagine if you have something to the 5th or 6th or 7th degree, it gets unwieldy pretty quickly. And so it's much quicker to set up this chart and then just take the product of each column gives you the value of each term, okay? So I'm going to use brackets like this just to keep things in order here. Okay, so 2 to the 4th is 16, and then x to the 4th. So, you know, I'm thinking 2x times 2x times 2x times 2x would be 16x to the 4th. 3 to the 0th is 1. So this is going to be the value of my first term. I don't know why I used the square brackets. It doesn't really matter. Okay, and then 2x to the 3rd, the quantity 2x to the 3rd. So this isn't the same. A lot of times people will just write 2x to the 3rd down here. No, because it's, think of 2x times 2x times 2x. It would be 8x to the 3rd. That's where the parentheses come in. All right, and then 3 to the 1st is 3. All right, and then 6. And then this is the quantity 2x times itself, so 4x squared. 3 to the 2nd is 9. I almost put plus, but I'm multiplying. I'm taking the product of these columns. Okay, 4 times 2x. And a lot of times I see people write 9 for 3 to the 3rd, but 3 times 3 times 3 is 27. So be careful there. I do it myself sometimes. And then we've got 1. 2x to the 0th. The quantity 2x to the 0th is 1. 3 to the 4th, that would be 9 times 9, right? 3 times 3 times 3 times 3. So 81. Okay. And then I start simplifying this. So that first term is 16x to the 4th. Next up, I'm thinking 4 times 8 times 3. So that would be 32 times 3, which gives me 96. X to the 3rd. 6 times 4 times 9 is 216. That's x squared there, okay? And then this is going to be 4 times 2 times 27, so 8 times 27 comes out to 216 again. And that was for the x term, and then 1 times 1 times 81 is 81, okay? Okay. All right, something that's also worth noting, notice how all my terms here are positive. That's because the A and B were both positive. But if one or both of them are negative, there's 3 different ways this can shake out. All of the terms can be positive, They could all be negative, or they can alternate. So those are the patterns that emerge when we're using Pascal's triangle. So Pascal's triangle is for expanding binomials, right? It's for taking binomials and raising them to degrees. So it's just another way to deal with these without actually multiplying it out piece by piece. And it still involves some work, but it will save you a lot of time. And that's it.